A student who starts designing web pages pays a one-off cost of $250 for the setup of software. So we can see that here he's not produced any web pages, but it's cost him $250. He estimates that each web page will cost him extra $30 for various online costs. The cost C for producing N web pages is displayed below. So we can see here that there's 2 additional web pages, and so this one has gone up by 60. And since these go up in 2s, we're going to go up in 60s. So this one here should be 370. Then we'll have 430, 490. Then the next one will be 550. Then 610, 670, 730. We now want to sketch the graph of n against c on the axes here. So when n is equal to 0, c is equal to 250. Now let's try to find some other good points to plot. 10, 550 would be a good one. So 10, 550, because we can get that exactly on a grid. The other points we can't really get exactly on a grid, but we only need 2 points for a straight line, and we know this is a straight line. So we can just draw the straight line through those like that. The student plans to charge customers $50 for each completed web page. Complete the following table, which lists the revenue income obtained from selling N web pages. So no pages is 0. Again, these are going up in 2s. $50 a page, so that's $100 for every 2. So this one would be 200. Then this one is going to be 300. And then we'll have 400, 500, 600, 700 and 800 here. On the same set of axes, plot the points given in the revenue table. So we have 0, 0, and then we've got 2, 100, and then 4, 200, and then 6, 300, 8, 400, then we've got 10, 500, 12, 600, 14, 700, and 16 would be 800. So if we join those up, we get a straight line. So we can say that the blue line, that's the cost, and the red line is the revenue. Given that profit equals revenue take away cost, use the graph to find how many web pages need to be designed in order to show a profit. So revenue take away cost. So that's red take away blue on this graph. So to make a profit so that this calculation is positive, it means that the red line needs to be above the blue one. Now it's certainly below at 12. It seems to me the first time it's above is here at 13. And we can always check that with a calculation. So 610 add 30 would give us 640, and here 13 would give us 650. So certainly at 13 it's above, so that's going to be 13. State the linear function that relates c to n. Well, we know that c will be of the form mn plus a constant. I call the constant k since this is c. So m is the gradient, k is the y-intercept. Well, we can see the y-intercept here, so straight away we have that k is equal to 250. And every time we went up by 2, we went up by 60. So if we go up by 1, we'd go up here by 30, so that's the gradient. So c is going to be 30n plus 250. And of course we can always check that with some values in the table. Now with r to n we can see, so if we say that that's equal to r equals mn plus a constant, here the intercept is at 0, so that gives us k is 0. Now every time we go up by 2 we go up by 100, so going up by 1 means we'd go up by 50, so that's the gradient, so r is equal to 50n. What are the coordinates of the point of intersection of the two lines? Well, the graph isn't really accurate enough to do that, but we can solve these simultaneously. So point of intersection is when c is equal to r, which means that 50n will be equal to 30n plus 250. So 20n is equal to 250. So n would be equal to 12.5. So if we do 50 times 12.5, so 5 times 12 is 60, so that's going to be 625. So that would give us that c and r are equal to 625. So that's going to be 12.5625. Work out the rule that gives the profit from the number of web pages sold. Now we know that P is equal to revenue takeaway cost. So that's going to be 50n take away 30n plus 250. So that's 50n take away 30n take away 250, which is 20n take away 250.